everyone. So we're supposed to meet, but we ended up having some crazy weather. So I'm just going to go through these problems here and record them. I'm going to use some old school document camera technology. So hopefully this is going to help. I'm going to do these videos in pieces so that you don't have to endure this for too long in one sitting. Okay, so I'm going to switch over to my document camera. This is my old school technology. So this is the PDF that I sent you all is week 1. And so these are the problems we were going to start working through. So let's take a peek. So I started off with reducing fractions. Fractions, everyone's favorite, as we know. So I started off with 5 over 25. So I rewrote the problem. And then I decided to divide the top and the bottom by 5. And we know 5 divided by 5 is 1, and 25 divided by 5 is also was 5. So we can reduce or simplify 5 over 25 to 1/5. Sometimes people learned it a different way. They might have learned it like this. So 5, they might have broken down 25 as 5 times 5, like those two factors. And then they could cancel out 5. You're allowed to do that. And that would turn into, well, there's nothing up top, so we're going to hold a 1 there, and then we have the 5 on the bottom. So whether you go by division right off the bat here, or write out your factors and do some canceling, then either way, it will get you to the finish line. Okay, so pause the video, try 12 over 40, and then come back, and let's see if we get the same answers. Okay, so if you're back, the first thing that I thought about with 12 and 40 was just attacking by dividing by 4 on the top and the bottom. So 12 divided by 4, we know is 3, and 40 divided by 4, we know is 10. So that's like the cleanest, simplest way to go for it, but you can kind of go a different way. There's always a different way to skin your cat here. So 12 could be written as 3 times 4. 40 could be written as 4 times 10. And then you could just cancel out those 4s and get 3/10. So hopefully you reduced 12 over 40 to 3/10. If not, take a peek at what I did here and see if this makes sense. You could even get a little crazier if you wanted to. And you could write 3 times 2 times 2, right? Because 2 times 2 makes the 4. You could also take that 4 and break it down to 2 times 2. That 10, you could break it down to 2 times 5. You're still going to end up with the same thing. We can cancel a couple 2's here, top to bottom. I still have a 3 up top, and 2 times 5 is 10. So there's some different ways to kind of think about reducing or simplifying. Okay, 13 over 52. Pause the video, give that a whirl yourself, come back, and let's see if we have something similar to each other. Okay, so if you're back, 13 over 52, it's kind of an ugly fraction. I know that 13 goes into 52 4 times, so I went for it this way. And then I canceled my 13s and I got, 1 up top because there's nothing there, 4th. This one's kind of tough. 13 is a prime number. It's kind of ugly. Can't really do too much with it as far as breaking it down. 52, you have a little more options. So this way here is about the simplest way that I could think of doing it. Okay, so let's move. Let's move to the next set of problems. So the next slide on your PDF was just a refresher. Many of you probably already know how to do all these things, but we just want to come back and refresh ourselves if you haven't done these in a while. It's nice to kind of get a little refresher. So 3/10. So we're going to convert between fractions. So we have a fraction here. Decimals, we have a decimal here, and percentage here. So we're going to have one of each on the buffet. Okay, so I want to give you some little notes here. So if you have a decimal and you want to change it to a percent, the simplest way is just to multiply by 100. Sort of like a little cheater. And just the opposite, if you have a percent and you want to convert it to a decimal, you just divide by 100. So we're going to keep that in mind as we kind of go through these practice problems. So as always, I want you to pause the video, come back, check your work. Okay, so 3/10, it's a fraction. It can't be reduced. All right, it's already in its simplest form. So let's try to put it into a decimal. So you could put this in your calculator as 3 divided by 10, and you're probably going to get something like 0.3. So we could get it out of its fraction form. We can get it into its decimal form. And then now that it's in its decimal form, we could just get fancy and multiply by 100 and turn this into a percentage. So there's the decimal format. We could multiply by 100 and turn that into 30. And now we have converted it from decimal form to a percent. 75 is already sitting in a percent format. We could convert it right to a decimal by dividing by 100. So let's try that. 75 divided by 100. If we put that in our calculator, you're going to do 75, the numerator divided by the denominator. You should get 0.75. If you want to now, you could multiply your decimal times 100. Let's go decimal to percent. We could put it back into 75%, which seems kind of silly since that's where we started. If you wanted to simplify your fraction, 75 over 100, you could think about this as quickly. You know that you could divide by 25 to the numerator and the denominator. 75 divided by 25 is 3. 100 divided by 25 is 4. So that's kind of one way to think about that. You also could have kind of reduced this. If you want to, you could have reduced 3/4, or excuse me, 75 over 100 by doing 25 times 3 and 25 times 4. And then just canceled out your 25s and end up with 3/4. So just lots of little things to kind of play with. We went from percent, put it over top of or divided by 100, that turned it into a decimal. If you multiply by 100, which is the exact opposite of dividing by 100, we went back to our percentage. If you want to take this 75 over 100 and reduce it, we certainly can do that. If you put 3 divided by 4 in your calculator, you're still going to come up with 0.75. So lots of different ways to attack that. All right, 0.24 is already in decimal format. Let's go ahead and multiply by 100 to get it to a percentage. So I'm going to play around with that a little bit. That's going to be 24%. If you want to put it into a fraction form, you have it as a percentage. So percent to, well, to make a fraction, we could just put 24 over 100. You can put anything in percent over top of 100. That's totally acceptable. And then if you want to, we can break that down. We could call 24 is 4 times 6. 100 we know is 4/4, so 4 times 25. And we could just cancel out those 4s and we can reduce that to 6 over 25. And if we were to put that in our calculator, I think we're going to end up, I'll show you that, and right back up with 0.24. So we have 6 divided by 25. There's a little bit of a glare on there. Let's see, yep, 0.24. Lots of glare there. Okay, let's move to the next slide. Hopefully this got you warmed up a little bit. Okay, so the first 4 weeks of MAT 205 are all about probability. So we're going to start off with exploring probability by looking at the fundamental counting principle. So here's a problem. Charles is vacationing in Germany and wants to pick out an outfit for a day of sightseeing. Charles must choose a shirt, a pair of pants, and a cap. Charles looks in his suitcase and sees 2 shirts, 2 pants, and 2 caps. How many different outfits can Charles make? Okay, so the fundamental counting principle tells us that we can take those 2 shirts, we can multiply that by the 2 pants, and we can multiply that by the 2 caps. And 2 times 2 is 4, 4 times 2 is 8. So by using the fundamental counting principle, we could tell Charles that Charles could make 8 different outfits from 2 shirts, 2 pants, and 2 caps. So using that kind of thinking for the fundamental counting principle, take a look at the second example. Give that a try. So pause the video and come on back. So Tammy's having lunch with Charles. Charles is vacationing in Germany, as we see. Tammy has budgeted for a special, which includes a sandwich, a drink, and a dessert. The menu offers 3 kinds of sandwiches, 2 types of drinks, and 2 desserts to choose from. How many lunch specials are possible for Tammy? So you're going to go 3 times 2 times 2. You're going to get 3 times 2 is 6, 6 times 2 is 12. So Tammy has 12 special combinations possible. Okay, so hopefully that makes sense. If you want to Google the fundamental counting principle, it's probably going to give you a very geeky definition, but I'm just trying to make it as simple as possible. Now, fundamental counting principle does sort of ramp up a little bit and add a little more spice to it. So let's take a look at this one. So I put a little harder example on here. A burger chain wants to send codes for a free hamburger to the members of its kids club. The coupon code will have 1 letter followed by 2 digits, followed by 2 letters. The letters RSTU and the digit 3 will not be used. Okay, that's important information. Assuming that the letters and digits can be repeated, calculate how many coupon codes can be generated. There's a hint I put here for you. There's 26 letters in the alphabet. We know that. Minus the 4 letters not being used. They told us those are not being used. So that's going to be the number of letters we can choose from. So 26 minus 4, we're left with what? 22 options for letters. Now, my hint for the digits are there's 9 digits that can be used. 3 is not being used. So that leaves us with 0, 1, 2. You'll notice missing 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So we have 9 digits that we can use and 22 letters. Okay, so I'm a visual learner. I need to see things visually. So I noticed that it says the coupon code is going to have 1 letter. It's going to have a letter followed by 2 digits. So this is a digit. This is a digit followed by 2 letters. This is a letter. This has to be a letter. Okay. So we step up and we decide, okay, so we're going to make a coupon and the first piece of the coupon has to have a letter. Well, we have 22 letters to choose from. So we're going to do 22 letters. Then we have 9 digits because it says 1 letter followed by 2 digits. So we have a choice of 9 numbers here, 9 numbers here. Have another choice of 22 letters out of the alphabet here for the 5th or the 4th and the 5th part of that coupon code. So fundamental counting principle just says that we are allowed to multiply these together. So it's going to give us a lot of options. All right, so if you check and double check me, 22 times 9 times 9 times 22 times 22, that is a lot of coupon codes. So we have 862,488 possible codes for the coupons. Okay, so hopefully that is going to help you think through how to work our way through the most difficult example of the fundamental counting principle. So, and these are all different examples that you're going to encounter in your ALEKS homework. I've changed the names and changed up some numbers, but you're going to probably see very similar problems to these in your homework. So hopefully this will help you. Okay, think about a buffet table. 7 different dishes of food will be placed in a row. There's 4 vegetarian dishes, 3 meat dishes. All right, so we have 7 different dishes of food, 4 vegetarian, 3 meat. All right, here is the kicker. They will be placed alternating between the 2 types of dishes. A vegetarian dish will be first. How many ways are there to place the dishes on the buffet table? Okay, we got 7 different dishes of food. So I want you to think about this. I want you to pause this video and maybe draw out 7 like representations of those dishes. Oh, that's a terrible box. Think about what's going to go in here, especially since they're telling you that a vegetarian dish has to be first. So pause the video and then come on back. Okay, if you're back, I wrote this first dish has to be a vegetarian, and then they have to alternate. So then this has to be a meat, then a vegetarian, then a meat, a vegetarian, then a meat, and a vegetarian. Okay, so let's think about this. We'll start off with the vegetarian. There's 4 vegetarian dishes we can choose from. So we're going to start with 4. Then we have 3 meat dishes we could choose from here. Great. Okay. Now, if we have, let me draw the little boxes here. This might help. And then here's your meat. All right, so here's vegetarian and here's your meat. Okay, so we had 4 to choose from. Once you choose to put this dish down first, let's just say for your vegetarian, you can't use that dish anymore. Then if you choose your meat, you're going to end up taking that dish away. All right, then you're back to vegetarian, but now you only have 3 choices. So this is going to be a 3. I'm going to cross that off. And then you can choose from leftovers the 2 meats. So we'll grab a meat dish. So we're down to 2. And then vegetarian, you still have 2 choices. So we're going to cross one off. And then we have meat, 1 left, and vegetarian, 1 left. So hopefully that made sense what I was doing here. And then with the fundamental counting principle, you can just multiply all these together. It's very nice. So 4 times 3 times 3 times 2 times 2 times 1 times 1. Let's see what we get here. So check me. All right, I'm going with my old trusty calculator here. I'm getting 144 ways. Hopefully you did too. So those are the 3 different levels of the fundamental counting principle you're probably going to encounter as you navigate through your ALEKS homework. Let's see what's next. Aha, probability continued. This will be the mantra for the next 4 weeks of the class. All right, what is a sample space? So you're going to start seeing these 2 words. A sample space broken down is just in probability theory, which is the concepts we're looking at these weeks. It's in sample space and probability theory is just the set of all possible outcomes, or sometimes they use the word results, that can occur from an experiment. So let's do a little introduction to sample spaces. Okay, we're going to start off with, let's write out the sample space of flipping a coin. How many outcomes? So if you took a coin out right now, how many outcomes would you have? So let's pretend here you are, you flip that coin. It's either going to land on, as we know, heads or tails. So there's 2 outcomes, heads or tails. And sometimes you were asked to write your sample space using what I call fancy pants. They're really just curly brackets, but your choices of what could come out when you flip a coin is heads or tails. And so you can kind of put your sample space kind of fancy, like in these little fancy bright, I guess they call them curly braces. I call them fancy pants. I don't know why, just it's in my head like that. Okay, so that's the sample space of flipping a coin, but let's get a little crazier here. What is the sample space of flipping 2 coins and how many outcomes could you have then? Okay, so think about this. Here you are, you flip a coin. It's going to land on either heads or tails. That's going to be your first flip right here. But then it says we're going to flip the coin again. So you could have heads or tails after you already got a heads, or if you got a tails, you could still on your second flip end up with a heads or a tails. That's your second flip. So there's 1, 2, 3, 4 outcomes. And if you want to, we can write these out with our curly braces here. So here's one potential situation. You could get H, a heads, and then another heads. Or you could flip and get a heads and then a tails. That's your second outcome. Or you could have flipped a tails and then get the heads after that. Or tails, tails. And then you could close that up with your fancy pants or your curly braces. Okay, so we're just writing out sample spaces of what could happen. So remember, a sample space is just writing out all possible outcomes or results from some sort of experiment. All right, sample space for rolling a 6-sided die. Well, we know that on a die, right, you could have a 1, a 2, a 3, a 4, a 5, or a 6. So I'll just put those in their little fancy pants. So you can have 6 outcomes. And I'm going to start writing some things off in the margin here just to sort of prep you for some things to come. So I'm going to write 6 outcomes times 1 roll. Okay, 1 times 6 is equal to 6. So this is not necessarily part of the answer that they're asking for here, but it's just me prepping you for future things that are coming to us, to a theater near us. Okay, let's see what's next. All right, continue with sample space. Emily has a coin in her hand and a box that has 4 cards numbered 1, 2, 3, and 4. Okay, so think about this coin in her hand. She's also got a box that's got 4 cards, and these are the numbers on the cards. Okay, Emily will toss the coin once and then record the toss as either heads or tails. Then Emily's going to randomly pick a card from the box and record the number chosen. All right, give the sample space describing all the outcomes. Okay, so a couple things going on here. She's got a coin, she's also got a box, so we need to be thinking about that. The coin in her hand, we know, is either going to be heads or tails when she tosses it. The cards she's going to grab out of the box is either going to be 1, 2, 3, or 4. So let's make some fancy pants, some brackets here. And let's think about what could happen. First, she could toss the coin and she could have it land on heads and the number 1. So I'm going to put those together. She could toss the coin, land on heads, and also get a 2 out of the box. She could toss the coin, get a heads and a 3 out of the box. She could also toss that coin, get the heads and the 4. Okay, so there's 4 outcomes that could happen. She also could, let's work with the tails. Get a tails and a 1. I think you know where this is going. A tails and a 2. A tails and a 3. And a tails and a 4. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Okay, 8 outcomes. And then it says, give all of the outcomes for the event that the coin toss is tails. Okay, well, that's just going to be these right here. So it's just going to be, let's fancy pants that. Tail 1, tail 2, tail 3, and tail and a 4. Okay, and I just want to put a little note out here. You have 4 outcomes here, 2 outcomes here. 4 times 2 equals 8. So just put that kind of off to the side. Just put that somewhere in the back of your brain. Okay, and then we'll talk about that soon. All right, so I'm going to stop this recording. When we come back in the next recording, I will start off with theoretical probability versus empirical probability. So stay tuned for another video coming your way.